And our next problem says the vertices of hij are h is at 1, 2, I is at -3, and j is at -5, 1. I want to find the coordinates of the orthocenter. So here's what we're going to do. We're going to graph this out first. So I know h is at 1, 2. Well, let me change colors there. I is at -3, 3. And j is at -5 and 1. Now what I'm going to do here is I'm going to construct two of my altitudes, and then I'm going to calculate where they intersect at. So I think what I'll do is I'll draw on this altitude first. So I'm going to find the equation of that altitude. So to find the equation of my altitude, I know it's perpendicular to my line. So I look at my first line here and want to find the slope of that line. So I'm going to say 2 minus 1 all over 1 minus a -5. Well, 2 minus 1 is 1. 1 minus a -5 is 6. So my slope is 1, 6. I know the line that's perpendicular to that is going to have a slope of -6. And I know it goes through the point -3, -3. So I'm going to write the equation of this. I'm going to say y plus 3 equals -6 times x plus 3. I think I'm going to get y by itself. So y plus 3 equals -6x minus 18. And then I'll subtract 3 from both sides. So the equation of this altitude is y equals -6x minus 18. No, minus 21. Sorry about that. -18 minus 3. Now I'll construct the altitude of a different line. And let's go from 1 to 2. So I'm going to do this altitude. I don't know if that's not quite right. I want to be at 90-degree angle. Okay, so if I draw in my altitude, and I want to make sure it's at a 90-degree angle, looks like it might be actually on the outside here, huh? So what I'm going to do is I'm going to find the slope between -3, -3, and -5, 1. So I'll start here again. So my slope, I'm going to go -3 minus 1 all over -3 minus a -5. Well, -3 minus 1 is -4. -3 plus 5 is 2, so my slope is -2. I know the perpendicular then is going to have a slope of 1/2. I know it goes through the point 1, 2, so the equation of my line is y minus 2 equals 1/2 times x minus 1. And there's the equation of my line. So I'm going to get y by itself like I did in the other one. So I'm going to say y minus 2 equals 1/2 x minus 1/2. Or y equals 1/2 x plus 1/2, which is 3/2. Now I want to find out where these two lines intersect, so I'm going to set them equal to each other. Since the y's are the same, that's the reason I got the y by itself. So I'm going to say -6x minus 21 equals 1/2 x plus 3/2. I don't like fractions, so I'm going to multiply my whole equation by 2 so I don't have to work with fractions. So then we get -12x minus 42 equals x plus 3. Now I'm going to get x by itself, so I'm going to get all the x's on one side. I think I'm going to add 12x to both sides. So we add 12x to both sides. And so we get -42 equals 13x plus 3. Subtract 3 from both sides, and we get -45 equals 13x. Divide both sides by 13. So x is negative 45 over 13. And then to find the y-coordinate, I'll replace x in one of my equations with negative 45 over 3. I think I will use my second equation here that has y equals 3 halves. X is negative 45 over 13 plus 3 over 2. So then we're going to, well, that's a 1/2. Sorry about that. My own handwriting got in my way there. So 1/2. So then we get negative 45 over 26 plus 3 over 2. My common denominator is 26. So I get negative 45 over 26 plus, I'd multiply by 13, so I get 39 over 26. And then negative 45 plus 39 is negative 6 over 26, which reduces to negative 3 over 13. So in other words, the coordinate of my orthocenter is negative 45 over 13 and negative 3 over 13. I chose to use substitution to solve this system. You could have chose graphing, or you could have used elimination, but you just find the points where both lines intersect. So as a review then,